course now. Some of you still don't know how to join the room, or they just don't want to join, or they joined and they're not. I visited some rooms. There was no discussion over the course of what it's all about, your assignment, which is fine. I do understand that. Anyway, let's share the presentation for this class. So as you saw in the video, it's basically we are talking about the manufacturing process. In the next chapter, we'll talk about service process, and then we will be going over some applications of the service process and manufacturing process and how it's done. Hopefully, we can finish it by end of today. So as you saw in the video, so we will continue and see the products, different type of products there. So the chapter 6 talks about the manufacturing process, and you will be learning about understanding the manufacturing process. What's the manufacturing process? Understand the production process, mapping, and the little laws, something called the little laws. Explain how the manufacturing process are organized, which is we saw some of it in the video, and understand how to design and analyze the assembly line. Basically, the production process is made of a three steps. The first step is the source, that part is needed. So what kind of products is needed there to do that. The second part is how to make the products. And the third part is the customer, the delivery products. So these are made of three steps that is a process, production process. Now the lead time is the time that to respond to a customer order. So when the customer is ordering something, is how much time you have to respond to it. And it differs from one to another. So the customer order decoupling point is where the inventories is positioned, allow the entities to supply the chain operate independently. So it's already the inventory has in a situation where they can supply this product to them. Lean manufacturing is as a process of ways of achieving a high level of customer service with a minimum inventory investment, as we said in the first few classes, something like just in time. It's one of the lean manufacturing process. Now, types of firms or operation organization is basically make to stock. So it means that the server customers on demand from the finished good inventories. Assembly to order is combine a number of pre-assembled models. It's kind of ready, but you can put them together once according to the customer specification. And make to order is make the customer product from a raw material, from a startup material, parts and component. And then you have engineer to order is you haven't done anything for it. First of all, you sit with the customer, you look at their requirement, and accordingly you try to build your products. Now, example of these products are, for example, if you have in the stock, you have example like a televisions, clothing, packaging foods. These are food product. These are examples to stock, make to stock. And it's an essential issue in satisfying the customer is to balance the level of inventory against the level of customer service. So these things is easy with the unlimited inventory, but inventory costs money. So you don't want to have too much inventories waiting in the warehouse because this is going to cost you money. So, but in the same time, you want to offer the customers as per its requirement and request. You can do that. So you have to do a trade-off between cost inventory and the level of customer service that must be made and the satisfaction level. So it's usually you use the lean manufacturing to achieve the higher service level for a given inventory investment. So you want to make sure you bring things just in time, you produce things on time, and you supply them on time to the customers. Now, a primary task is to define a customer order in the term of alternative component alternative components since thank you very much. These are carried in the inventories. Sometimes, usually like a Dell computer, you have, you wait for the order because the issues is that you might, customer looks for a certain specification like in the RAM or the size of the PC or the speed or the screen. These are all, different components that you put it together. So you assemble to order, and the more component, the total number of combination component there, the higher number of different type of, for example, Dell PC you prefer, you prepare. One capability required to design that is enabled, as we said, is usually it looks like a wide varieties of selection. So this is why you have the components is ready and you just put things together and you give it to the according to the need of the customer. The other type, as we said in the video, and also in here, is make to order or engineer to order. For example, Boeing process for making commercial aircraft is a good example. First, the people, the customer makes an order, and sometimes takes over 10 years to deliver an airplane, or yes, 10 years, because it is, you have to first order and then they make it, or engineer to order. So there is a certain specification you might be looking for. So they have to sit with you and find out what you exactly looking for. And then this where is the, you make the order. Customer order decoupling point could be better in either raw material at the manufacturing side or the supplier inventories. So the decoupling, it doesn't have to be, in your warehouse ready, because you are gonna have time to sit with the customer and take its order and how it's supposed to be built. I think that one of the other options that you're looking at, which is you're utilizing it, is the buses that you write sometimes. These are all built in one manufacturer, but each one has a different blueprint, shall I say. The same manufacturers, I think, in New Flyers, is called. They make buses for bands, musician bands, for this, for the politicians, for the buses, transportations. So they have different for the jails, for hospital. They have they wait for you to make an order, and then they engineer it according to your to your customers or to your need to do it. So that's the difference here. Now, this is the production process mapping, and it's basically um, it's depend on what you have, develop a high level of map for your supply chain process. So you need to look at your supply and the process of that's how the supply is happening in order to understand when you're going to get the product and how you minimize. We took also in chapter 3 for talking about you know, how we minimize the risk of, you know, the supply might not supply you or mitigate the risk of supplying. So you need to develop a high level map of supply chain process and how this process is happening from outside to the inside within the corporation to the final good. Useful to understand how the material flow and where are the inventory held. Some the closest is the inventory, the better. If you notice, for example, recently most of the companies try to do the inventory very near to them because this is might take less time, less effort, and less risky to take to deliver the raw material from the inventory from the warehouse. And the first step is to analyze the flow of material, which is in the production process and how it's done. And if you see this here in the histogram, says, well, the supplier supply you with the sources, then you're going to see the transit. In the transit, you need to have some buffering places, buffering in the raw material. So you have like at least 20% of material standing there, raw materials, just in case if the supplier is not, for some reason, was not able to send you this. And then you do the factory and you do the processing. And also when it comes to the good, you need to have some buffering there to make sure that, you know, if something goes wrong with the factory, at least you have goods is ready to be delivered, and the time of the transit that to deliver to reach to the customers. So these are the things that you need to look at it when you're doing a production process in the manufacturing. So the little law, it says that the flow of items through a production process can be described as probably using the little law. And it says that inventory equal with the throughput rate and flow time. Now, what's a throughput rate? It means the long-term average rate of the flow through the process. So how long it takes to have this production is done. The flow time is a time for a single unit to travel, to traverse the entire process. So the single unit is different, the whole time of the things is getting processed. And inventory, which is it is the material held in the firm. So these are the three process of to look at the little law, which is inventory, throughput rate, and flow time. So if you want to look at the throughput rate, then you will go inventory divided by a flow time rate. Now, the inventory is basically, we're talking about the measurement, the total average value of inventories. So there is some terms that accountants use, some terms that operation management use to to measure whether the business is running efficiently or it needs some improvement. So it's a very important for them to look at these two things. And basically is the total average value of inventories. And this is used in accounting, the sum of the value of the raw material, work in the process, and finished good inventories. So everything before it goes to the customers is calculated as by financial statement to see the cost of the inventory, whether the product is getting produced or in the warehouse or final goods and still in the warehouse. They're all cost of the inventory, cost of good producing. And inventory turnover is the cost of goods sold divide by average inventory value. So the cost of goods sold probably they use it because they want to see how much you are keeping as inventory versus how much is costing you to produce one unit. And the days of supplies, which is the inverse of inventory turn skill. Now, the organization of production process, it basically talks about the project, type of project, the work, the product remains in a fixed area, and the equipment is moved around the product. So you have the product never moves around, and the equipments keep coming to adjust to produce this product. And we talked about the work center, which is the shop. It's similar to the equipment or function are in a group. So there is a group and it's different group, and each group, they have a kind of, they come in and start working on the product, and it's like a work center there. The manufacturing cell, they are the different work of processing organization. And manufacturing cell, all you need is probably need the definitions, but the manufacturing cell is a dedicated area where the product that are similar in a processing requirement are produced. The assembly line is where it's a most famous one and usually used in lots of manufacturing, is that the work process are arranged according to the progressive step by step which the product is made. And in the car manufacturing, they use the assembly line in the lab, in the PCs, in mobile. You see the product is moving and they put things on it, and it keeps moving until it comes into the final finished good. And the continuous is the ones that is like as a very simple product, but the high quantity, there is no variety in it, and usually is produced, keeps going. And this is kind of different kind of, it's not assembly line, it's just a few equipment that produce the similar things on without stopping. So these are the different kind of, probably if you want to look at them, it's a production process. So in general, the product process probably works this way. As we said, is first of all, you need to look at whether there is a mass customizations happening or there is insufficient process. So inefficient process there. Basically what you're looking at there is if it's a low one of the kind where it is under demanded high is a continuous process. And if it's basically if the product is a high volume, so if it's a high standardized and it's a low, then you will get a continuous process. But if it's the product is a standardizations and the product volume is not very high, is like a manufacturing cells is happening. So you need to look at this and see where the product is, your product is looking at situation, whether it's a one of the kind and it's low, or high standardized commodity product, and whether is the volume is high or low. That's usually will be defining the thing, the process is done. Now, the production system design, um, we have we look at the how the production it's happening and how we design. Sometimes that makes a big difference whether we're going to need more people when the work is the load is high, or we need less people. So this is how it's done. The project layout is the product remains in a fixed location. So the product never move, and a high degree of task ordering is in common. So the product stays there, and there is high degree of people you're making the requirement to come in there and to do these things, and the project layout may be developed by arranging the material accordingly to their assembly priorities. Like, for example, if you look at the building a plane or a jet, is usually is a one spot, and the products comes in there and the assembly comes in there to do that. Now, the work center, it's different. And the work center is most common approach to develop this type of layout is to arrange the work center a way that optimize the movement of materials. And sometimes it's referred to a department focus. So it's focused on a particular type of operations usually. Um, Now, if you look at basically the production system design, as we said, the manufacturing cell is formed by allocating dissimilar machine to one cell are designed to work similar products shape. So there is a one cell works, if there is another cell works similar, and there is a third cell, and they have all type of machine in that cell and all type of machine in that cell, and all so it's like this is how they are working with each other. On contract, the assembly and continuous line is, as we said, is like the cars, how it works, and there is a same kind with a little varieties as like building a cars assembly line. And continuous, as we said, you have one product, there is not much customization needed, and it keeps producing the same type. So all the machines are very similar to each other. Let me know if you have any question. Now, as we said, we spoke about manufacturing cell development, and it works that way. So it's a group parts into a familiar that follows the common sequence. So if you will look at it, once we try to see how this was going to work. So it is, as we said, is there is a different cell, and each cell made of different machines, and these machines are not similar to each other, and they're producing certain levels, so they're moving near to each other, the product beside each other, and they're producing it and then moving it to the next cell to do the next steps on it. So work center layouts, similar machines in this center and this center and this center, and they do the same processing for it. Now, so if you look at this, this is how it's working. Usually it goes here. Usually the same machines here and very similar, same machines. The total of these same machines is similar to these, but inside each cell, they have a different equipment, different machines, something like that. Or the best look at it is you make it as a cells, and each cell has the same machines, but they are, laid out differently. So if you're looking at this one, it's very similar to this one, but they have all same equipment here. Uh, very similar to each other. Some adjustment there to do some adjustment for the final product. So you would see lots of common, for example, drilling, but there is one who puts plastic on it, the other one who puts a wood, which is they're different on each other. So this is where is the difference is happening, basically. Now, so the manufacturing cell layout dissimilars machines grouped together in a product cell. And the assembly line design, which is the most used one, is the workstation cycle time, and how it's the time interval in which a moving convey passes to a series of workstations. Assembly line balancing is it is assigning the task to a series of workstations so that the required cycle time is met and ideal time is minimized. Now, I will show you later on how it looks like for you to understand better what we are talking about. So the president's relation, in order to which task must be assembled. Now, before we start that, I would like to give you a break for 10 minutes, and we will be coming back again at 10 after, now is 10 after 2. Please come back at 10 after 2 to talk again about this chapter. Hopefully we can finish it before the class over. As we said, we spoke about the assembly line design and the workstation style time, the assembly line balancing, and the president's relationship in which the task must be performed in the assembly process. Now, then the next step is like we look at the example. This example talks about level of efficiencies. And once we do the different workstation, we probably do some time calculation to do the level of efficiency. So if you notice here, we have a workstation 1, which takes 45 seconds to produce it. And then it goes to the workstation 3, because we have another workstation, which is 2, takes 50 seconds to produce these things. So accordingly, we divide each workstation with the processes done, and then because we want to see eventually how these things takes time, and once it's because we have a few workstation, we want to move things according to the timing to move from one workstation to another workstation just in time. So just in case the next workstation would not stay, without producing. We do the time calculation for this. We would go more in the time calculation when we talk about the service processing chapter. Now, to reduce the time requirement, task time requirement, there is different options that we can work on it. One is we can split the task. The second, we can share the task. We can use the parallel workstations, and I will show you the shapes and how they look like. And we can use the more skilled worker, more efficient, so they can work more on it. They don't need to move the task from one station to another station. They can do it all in one. And we probably can do work overtime or redesign the workflow itself. So these are the options of reducing task time to look at it. Now, this shape, the flexible line out, it's, if you notice here, when the product, the work comes in here, these people are not looking at each other. They're, you know, so the product comes in here, he fixes it, he does his process and send it to go way down. And each one will take, so if anybody is slow, that will probably slow down the flow of the product. So the problem, operators trapped in cages, preventing sharing work. So they're not sharing work with each other. To solve this problem, you look at it and you move these, 8 people or whatever facing each other so they can share the work. And if he misses or he slows down here, the next one will continue, which is faster, can do it. So the solution is to remove the barriers to the operator that can trade work, and operate can be added or removed as you wish. Um, the other problem here, when you have the material lying on behind, so this station is basically, his operator is called bird cage, and with no opportunity to share the work or add a third operator. So this way is like he takes the product, he processes it and send it to the line, and they cannot share some behind work, or work is needs more attention to it. But the best way to solve the problem is, the fact is, the products, they can sit in this way where you can add one more person easily, and they can share the work together, where if there is this, the problem comes in, basically, the situation here in the first one is the operator birdcage with no opportunity to share the work or add a third operator. Here you solve the problem, operator can help each other, and the third operator can be added in this situation. So this is where you can, give it more flexibility. In the situation here, if you notice that the problem is a straight line, it's difficult to balance things. So things, if it's moving very quickly, it's a very difficult to balance accordingly. But if it's in a U shape, solution U shaped, line give better operator access and may reduce the need for operator. So it will give more flexibilities to share the work. So one more thing we want to talk about it, after all talking about these different shapes of setting the production. And we said that the fact how we can do that, we can split the task, we can share the task, we can use a parallel workstation, we can use a more skilled worker, overtime, give them more time, or redesign the shape. And we redesign the shape is, like we said, that they could be done, which is they cannot share the work. Here, where they can share the flow work. Here, there is a situation where the workers are not connected to each other, and they are in a bird cage. They cannot, cannot add one more. But in this case, You can add one more if it's necessary. Here that the problem is a straight line, is difficult to balance between them. Here is a review line, so it's easier to balance the work between them. So each one will take the work and pass it to the end line. Now, one more thing that we need to talk about it in the process manufacturing is the break-even analysis. And in the break-even analysis, what we want to talk about is um, the sometimes you are working on something, and this product that you're working on it, you're using the manual tools, the simpler tools, and they take longer for you to finish this thing. But most of uh, people would like something that like a a powerful drilling that works in electricity instead of a hand drilling machine. Um, but that costs more money. So there is a trade-off, how often you use these things versus how much it costs. So you need to look at the balance, the break-even analysis, whether it's worth to buy or a new equipment, or you bring it semi-finished good, or you use your old equipment and you do it slower. So the choice of a specific equipment to use in a production process can be based upon an cost, benefit, cost trade-off. Um, Often the choice between the specialized and general equipment. In a manufacturing, you do, use specialized equipment may require higher investment, but can perform more efficient over long term. So if you buy a big equipment or an efficient equipment, it's gonna cost you so much. But if there is enough units to go through it, makes it worth because you're gonna do a trade-off, cost trade-offs for it. So this is like how you look at it. Now, general equipment often has a lower initial cost, but lack of efficiency and takes longer to do it. So this is why you do a break-even analysis. You want to see at how many units uh, it's going to help you to do a break-even analysis for the new specialized equipment. Let's assume that if you have something that you produce and costs you right now, say $1, and it takes you produce 60 of them in 1 hour, and then you bring in an equipment that's very specialized, costs you so much money, but you're still going to produce only 60 of them. It takes you 10 minutes, and then you have 50 minutes doing nothing. But if the new equipment you bring, that can produce 60 of them every 10 minutes, that by end of uh, 1 hour, you have 640, assuming that there is a demand for producing 640, something in like that sense, you have to do a break-even analysis. So one mean of choosing between two options is the break-even analysis. Understanding how profit and loss change for each option as the total number per unit. Um, this particular suitable when the process has been significant initial investment. So if you're buying an equipment which is cost you $1 million, you need to justify why you ask for this $1 million equipment, replacing the $10,000 old equipment, which was producing 10 units, and you need a new equipment which is produced 100 units in 5 minutes. It's much shorter term. So there is fixed cost in it, and which is initial investment, and there is variable cost to the number of units produced. These two things you need to calculate them to see how it's done. Now, as an example, to make it easier, We're gonna look at um, probably a manufacturing considering a three option for obtaining a machine part. The first one is say, well, the option one says buy the part from the suppliers for 200 per unit. No fixed cost. You just buy ready-made and you just continue with that. The second option, make part on a semi-automatic lathe for a $75 per unit. Um, so you're buying it, not a full equipment, part of the equipment where it costs you around $80,000 as a, a fixed cost, and costs you $75 per unit. So here you want to see whether it's worth to buy a machine which is cost you $80,000 plus $75 per unit. So you multiply the purchase cost, which is $80 plus $75 per unit, into how many is needed. Now, if you want to buy a full setup machine, which is going to cost you $200, $200,000, and you're not going to use from the supplier anymore, but the full setup machine will cost you $200,000 as a fixed cost, as initial cost, and plus $15 per every unit you produce. So what you do here is basically you compare it. And there is an Excel sheet, but we're not going to look at the Excel sheet. First, you're going to do a break even between point A, which is buying it from the customers, suppliers, everything, to total cost for option two, which is buying semi processed equipment. Now, semi-processed equipment is cost $80,000 and each unit costs $75. Now, if you're buying, you compare it with a full option, which is cost you $200,000 and each unit $15. So you look at this option two and option three. And then, there is one which is the demand or the quantity that's going to need it for to be produced. And you see the difference that you have to invest from semi product to a full machine producing. You have to add another $120,000 beside the $80,000 that for semi good. And here, where you can see that you need to produce 2,000 units in a certain time, or this machine should produce 2,000 units in order to do a break even and go through the stage three instead of stage two. On other hand, if you are looking at buying straight from the supplier, which is cost you $200 versus you buying semi-finished machine, which is cost you 80,000 plus $75, then you need to do the same calculation and find out how many units that you need to produce. So to produce if you're planning to buy a semi-finished good machine, you have to see that the demand for it is 64 unit. So you can go to your boss and says, okay, I need you to purchase a semi-finished good machine. And if he says why, you tell him that there is a demand of this machine can help us to produce at least 64 units, and that's where we break even. We don't need to, produce it. There is more variable goods, but to simplify this break-even analysis. So if we put it in the graphs, we're going to see that the fact that the break-even analysis at the point B. So the more you produce, the more units is you buy this. As you buy more, is this the line is a straight $200 as per unit, and the more you produce in the beginning is very expensive because you're buying the machine at $80,000 and it keeps, you know, the cost is higher than buying it. But at 640, which is this point B, is where you become a break even and then you start saving money. Then you're buying the machine from the customer, from the supplier. But when it comes to the buying the whole set of machine, you need to make sure that the demand is way over 2,000 units. And when as a startup, you have to pay $200,000 and you can keep on producing at the loss. When you make a 2,000 unit, then you're making a break even and then you make a profit. So if you notice here, the gap is a very smaller and later on. Yet here, the gap is much bigger as very quickly you can cover the expenses. And when it comes to a break-even point, machine center and buying option, the option here, uh, the revenue is not really breaking even with the other. So the break-even point between the machine center and buy option is not relevant because it, you know, you keep buying the $200 unit and you process it. So it's not even, it's a totally out of the picture. So the options is between point A and point B, which one you would be going for. And it looked like from the beginning as a safe side startup is the fact that um, if the demand, you do the calculation from the marketing, from the sales, you get the numbers needed, and then you do the calculation or the historical calculation, and then you decide which one you're going to do that. So these is what you call a break-even uh, analysis. Now, with this, we have finished this chapter. We're going to move on with the next chapter. It's rather, the next chapter will be talking about service processes. Most of us will be more familiar with it, but the second part that we're going to speak about it is that we're going to talk about more applicable option. See, there is two way of understanding a business. One way is really to do um, probably the business, and that's the best way to do the work in the manufacturing. This is the best way. The second part to understand how the business happening is to look at probably the applications is used to international big application which is used in a business. They are they call them the best practice. So once you understand how the apps is working, you definitely there is a functionalities within the organization which is utilize this part of functionalities of the apps, which is it tells you exactly how this is going to work. So the second half of this chapter, we're going to be mostly talking about uh, the different functionality within apps and this apps, how it's applicable to today business, because these functions did not being produced if they are not applicable to the business of today. So we're going to go and start talking about the manufacturing process. And but I think before we do that, um, let's have a very quick look at the video here on the service, because here we're going to talk about mostly service, and we're not going to see the whole video. This Zappos,
The Zappos.
just to give you an understanding, this Zappos company is now is one of the Amazon's companies, and being purchased by Amazon at the price of 1.2 billion. So it's a big operation. And I'll just give you a very quick look at it, and then we will go to talk about the service processing.
Zappos' slogan is "Powered by Service." What started as shoes has expanded into handbags, apparel, and accessories. Their ultimate goal is to be the company that provides the absolute best service online. Zappos believes that when it comes to online purchases, immediate gratification is a critical issue. The speed and ease at which a customer receives a purchase plays a critical role in whether or not that customer will shop with you again.
We're growing very, very quickly, and our biggest challenge is that we need to hire good people and get them in, trained, and continue to be motivated and to add value to the company.
Probably the #1 challenge is just hiring people, finding people that are passionate about customer service, because that's what Zappos is all about. And it's not just for what we call our customer loyalty team, our call center, but for everyone that joins the company. Because if the Zappos brand is going to be about the very best service, then everyone who joins needs to be passionate about customer service.
There are not a lot of companies where you can go and just rave about their customer service, but the few that provide really great customer service, you have a very, very loyal following. And I think that's what has helped Zappos over time. From a business standpoint, that loyal customer base has turned into, on any given day, 75% or more of our sales are to repeat customers, customers that have purchased from us before. So we're not constantly remarketing to customers and trying to acquire new customers.
You have to hire people with great attitudes and that want to provide great service. And so we've refined our interview and hiring process a lot over time to make sure that we are getting the right people with the right attitudes.
You may be an accountant or you might be our general counsel. It doesn't matter. We care so much that you understand our history, our culture, and what we do for the customer, that you go through 4 weeks of training, 3 of which is in the classroom, a week on the phones, and then we send you to our warehouse outside of Louisville, Kentucky, so that you can pick, pack, and ship for our customers and understand the guts of the business before you start whatever you do.
When we started out, our tagline was the web's most popular shoe store, but that didn't really make sense as we expanded into handbags and apparel and so on. So we need a new tagline, and just like the products that we add are based on customer feedback, we asked our employees for feedback on what they thought was an appropriate tagline, and we knew that we wanted something that would communicate that Zappos isn't just about shoes or any specific product category, that our real product is great service. And so we just thought Powered by Service made the most sense.
Now, this is our receiving dock. This is where all of our shoes come in from our manufacturers and distributors. These conveyors will extend into the trucks, and as the trucks come in, we'll unload the master cases, load them onto the conveyor, and then the conveyor will take it to the receiving station that it has to be received at. All the conveyor has inline barcode readers. There's barcodes on the sides of the boxes, and as the box goes through the conveyors, it decides where it needs to go and routes it accordingly. Kind of on average, on a typical day, we can get about 20 to 30,000 units or pairs of shoes in any given day, and sometimes as much as 60,000 in one day. After the truck, the items are automatically diverted to each one of these individual receiving stations. We have 20 of them right now. We can run 20 at one time. The receiver will open these cases, take the individual items out of the case, and there's a manufacturer's UPC on each one of these. They'll scan that item, and one thing that we do is a little bit different. We put an individual barcode on every single item. So every item, even if they're identical, will have individual serial numbers, so we can track it from cradle to grave, the history of that item. And then that also enters it into our inventory system and receives it. That's the point of receipt for us at that point. After the item is received, then all the receiver has to do is slide it over onto a takeaway belt that will then take it through our system and put it into our inventory system for storage. Customers will often have to return an item because it's not the color they expected. It doesn't look exactly like what they thought. Maybe it doesn't fit as well. So they return the item, and all of the items come back here to return specialists. And these are our most highly trained teammates that we have working here because they understand a wide variety of products. This merging system right here, and we call it the spider merge because it looks like a spider with a bunch of legs. What this was designed and installed for at fairly big expense was to speed up the conveyors. The original configuration of the building, the first design iteration was, and very typical what almost all warehouses or distribution centers look like, is you start on the first floor and you serpentine up to the second floor, then the third floor, then the fourth floor, and then out to outbound. The problem with that is we had a 35-minute conveyor travel time with that system from the furthest point of pick to our outbound system. Since we want to be able to fulfill our orders in an hour or less, we can't afford to let it sit on a conveyor for half an hour. So now we have everything on all floors come together in this spider merge, all merges together and then goes to outbound. So now our conveyor travel time is 5 minutes instead of 35 minutes. Everything is 100% completely random access stored. By storing it completely random access, it's actually much more accurate from an inventory standpoint. The item is almost always going to be where the computer thinks it is. Our inventory accuracy is better than any company I've ever experienced with before. We have a quarterly audit from our bankers that audit our inventory. I know from personal history for the last 2 years that they've been auditing us, we've never had an inventory discrepancy, not once in 2 years. So that's one of the advantages of that. The other advantage is if I store things together by size, color variation, and manufacturer, and I sent a picker there and I said, go pick a 7.5 Clark's brown certain model of shoe, they're more error prone. It's hand-picked from here. We use RF scanners. We don't do any paper picking or pick from list. But the system will direct the picker where to go, what to pick, and they pick it and put it on a takeaway conveyor. It's always a moving number, but we have over 1,100 brands in inventory right now on our website. We have over 900,000 SKUs. We have over 3.7 million units in inventory in this building. So there's, it's pretty staggering numbers. We sell about 27,000 units a day right now this time of year. We expect to sell about 60,000 units a day at Christmas time this year. Right now, our average, from the time a customer clicks the button until it's sitting on a truck ready to go to our carrier, is about 3.5 hours, which is very fast. And that's an average. So there's a fair amount of variation in that. We do many of our orders in under an hour. And different times of the day are faster than other times of the day. During the daylight hours, the early hours, the morning and afternoon shift, we're actually a little bit slower. We have a lighter number of workers in the building because the critical truck pulls to get it there the next day are all at night. So processing it in an hour or less right now is not very important because it's just going to sit on the truck until tonight. Tonight, it'll be crucial. This whole building is 832,000 square feet, or roughly 19.8 football fields under roof. We only built in, initially last year we moved into this building, we only built out half of that building, so 416,000 square feet is in use right now. However, in January of next year, we're going to have to start building in the other half. We have 23,000 feet of conveyor in the building. We have 5 sliding shoe sorters that are diverting things to different parts of the building. About 2/3 of that conveyor is broken down for the outbound post-picking processes and shipping process, and about 1/3 of it is on the inbound side for returns and receipts. This area up here is our box manufacturing area for erecting boxes and delivering it to packing. Everything you see in this lane is all singles processing or singles packing. And what the packer's doing at this point is they scan the barcode on the item. That scan then initiates a packing slip to be printed. She's putting a barcode on the outside that peels off that packing slip. That's now the order ID for that item. So on the shipping line, there's another sorter after we put the label on the outside. And what that does is it will divert automatically down to a dock that a UPS truck is at, or a FedEx truck, or a Postal truck is at. If it's a multi-order, the system knows that, and it will automatically divert it to this side, which is the multi-sort area. If you see, we have several of these shelf units, and each one has a barcode. That's a location. Each one of those locations constitutes a customer order. We have several of these divert points, which is for that range of bins. Now, the system knows which bin that item is supposed to go to. So it'll automatically divert down the appropriate lane. It won't just randomly go down a lane. It'll go down a lane that's next to the bin that it's supposed to go in. So the sorter then takes the item off of the divert, scans it, and it tells them what bin to put it in. Once the order is complete, there's a printer in the middle of the shelf unit that will print out a packing slip. That packing slip is the cue for the packer on the other side that that order is complete. What they will do then is they will scan the packing slip, which opens that order up. They'll scan the bin, and they'll scan all the items in that bin. What that does is, if in case somebody accidentally slotted it to the wrong side or whatever, this is the last quality check to make sure that we have the correct items in the right bin going to the right order. So they pack it on the other side, and once they pack it, they put it on a conveyor, and it goes off to shipping in the same area the singles do. At that point, it's an order in a box. It's completed. We keep an eye on our order cycle time throughout the day, how fast our orders being fulfilled, how many orders we have in the bucket, the workable bucket, the picking bucket, you know, the variety of buckets, so we know how to manage the workflow through the building. We have as close to a continuous flow process as I've ever seen. As orders come in, it's almost liquid the way they flow through our system and flow out. We don't batch anything up at all. The other thing is all of our systems are homegrown. So we've written and developed all of our systems the way we want them to be, not the way a particular vendor would give them to us. The hardware is the hardware. It's pretty standard stuff. But the software and our methodologies behind it is what's unique to us as opposed to other companies. We've grown a lot since we've moved here. 5 years ago when the company moved here, we had 20 people in 50,000 square feet with about 20,000 pairs of shoes. And now we have over 1 million square feet in total between two buildings, 832,000 feet in this building, 500 people, and 3.7 million pairs of shoes. So that's a lot of growth.
Okay, so you've seen this is about a service that providing is basically what they do. These orders that you make for buying a shoes, for Zappos, is basically they do make this order with the manufacturing internationally, and they bring it to them, and then they just repackage it and send it to you. It's a very similar to Amazon. This is how it's done. As a drop shipping and all these process. Now, just to talk about the services and different kind of services, we will talk about probably today is more about the process of the services, and we will hope that we can finish some part of it, not everything. Now, you need, in this, you will learn, understand the characteristics of the services. What makes services different than manufacturing? And then analyze a simple service system, how it works, and understand the waiting line, the queuing. And then the add-on part of it, as I said, we're gonna start looking at it from a different angle, which is looking at tier 1 and tier 2 applications that is used for customer service and used for individual service. So when you go to now after that, when you go to any company like a telephone company or an operating company, and you know why they ask you for your phone number or your name, so they can enter it to the system. And it's something called, probably you heard of it, Customer Relationship Management, CRM. And part of it is all built on the process system. Behind the customer service CRM, there is the business analysis and there is a business intelligence application. They're all built for meeting the requirement of the companies. And what the company does is that you can see, first you can see it directly. The best analogy that I can use, metaphor I can use, sometimes you look at things directly, and sometimes you have a mirror, and you look at the mirror, and the mirror showing the realities there. So let's think about when we analyze the application, it's really connected to production that is happening in the market. Now, basically, every service has a service package, a bundle of goods and service that offered. And the bundle is consist of 5 features. Now, the first feature is that the supporting facilities is the physical resource, such as the building, the equipment, like what you saw in the film, the shop, the place where there's physical existence. Then you have the facilitating goods, like the material purchased by the customer or provided by the customers. So the customer ordering a shoes, it comes in there and they repackage it and send it to the customer. And then you have the information, the data that provided by the customer to enable efficient and customized service. So they can see the order and then they can provide, the requirement. And then the explicit services, which is the benefit that are readily observable, which makes the essential feature of the service. So when you go to a store, mobile store, or you want to pay your bill, there is 2 parts of the services that you see. Services that you can see, it's done, like taking your mobile, trying to fix it, or these things. And then they ship it back there, which is that you cannot see. And then the implicit services, which is the part where when you walk into that store, for example, it's different when you walk to, if your mobile is, you bought it from a package from the bill, then you're buying it from no-name store. They're both probably purchasing, getting it from the same source, but it's a different psychological benefit that you're gonna feel about it, the prestige, the privacies in it. So these are the 5 features that you look at in the service. Now, in general, the operation of classification of services is very straightforward, and it's a service organization are classified according to the customer they service and to the service they provide to the customers. So it is classified to the customer they service and to the service they provide to the customer. There is a customer, how heavy is there is a customer contacts, the physical presence of the customer in the system, whether he's there or not, the creation of the service, the system with, as we said, the physical presence of the customer in the system, whether the customer is there or just he's doing the order online, and the service system with a high degree of customer contact are more difficult to control. So the more is there is a customer is there, the harder is to control the work process that involved in providing the service itself. So what's the process needed to provide that service? Probably changing the car oil when you go to loop, it's different than you go to a doctor to check on you, then you go to a store to get a SIM card. So these are different level of your customer contact and what type of services is created and the process involved in providing the service itself. So these are the things that you need to look at it. Now, the service organization design, the service cannot be stored. This is what makes it than different than the product. It cannot be stored. It's if there is nobody's using that service, is gone, and you have to pay for it as a as a owner of the business. So you pay for the person to be there to provide service, and if there is nobody's there, then the service is just cannot be stored. So the capacity becomes more crucial. So you don't have an inventories, and if you have 10 people, service provider, and you have one person coming in, then you might facing a problem. And if you have one person provide the service and 10 people comes in to get the service, you also might face a problem. So there is a too much capacity lead to excessive cost. Insufficient capacity lead to the customer cost. So you need to balance these two together. Enough capacity, enough manpower to provide the service for enough customers. One of the ways is to provide the waiting line models, provided a powerful mathematical tool for analyzing many common services. There is things that you can do with the waiting lines, the queue lines, that it can help you so much to really manage your capacity versus the number of the customers who's going to be coming in. So the way you look at it, the service system design matrix, it works like this. There is the degree of customers or server contact, how many contacts and customers is coming in, and there is the sales opportunity, whether you are looking to do a sales or not, whether you are looking to do upsales or not, and there is also the number of coming. So when you do a mail contact, you're not expecting to make so much, sales, and there is a buffered core, and the more it goes in, like internet on-site technology, the more you go on a production low efficiencies, but then you have a better chance of making sales, and your production efficiency would be less. But these are two is determined by your goal. What's your goal if you want to make more sales? And the second is whether you want to be more production efficiency. But who determines that is the degree of the customer server contact. So face-to-face total customization is usually happens in the hospital and with a doctor and dentist or a lawyer, where you have to more provide services, and it there where you charge more, but the production efficiencies is kind of going low, but there is a chance of making more sales during that part of action. So this is a way of looking at it. It's basically when you have a contact, and degree of customer and server's contact is what you need. If the degree is a very low between the server who provide the service and the customer, if it's a very low, then you need, for example, work requirement, you need a clerical person. But if it's a very high, you need somebody who do a diagnostic skills, a trade skills. So it's depend on how much is this level determine where you want to be fit from worker requirement. Now from focus and operation, then you look at if it's a low, they just do a paper handling, just like you saw, it's just you do the scanning and you forward it to the others. But if it's a very high, you need to do probably a capacity management and a client mix, and in the middle, probably scripting. So this degree of customer server contact is determined is what kind of a worker requirement as a skills. It needs to focus, what kind of operation it needs to be done, and the technological innovation, whether you need an office automation or you need an electronic aid like such as RFIDs, a self-service, or a client worker teams. These are all determined by this level, how high and how low you need to look at it. So the processing mail at the US Postal Code, it's a very similar, this what you want, you're looking at. The software support service, troubleshooting, you need somebody with a verbal skills, scripting calls, and computer database. And here the certified, you need somebody like a certified accountant or a doctor or attorney. You need somebody with the diagnostic skills, a client mix, and client worker teams. Now, we'll finish very soon. This is the light slide. We will talk about it probably. This is only a sample, and we'll start next class. Please turn off your mobile. Now, customer service is the new role of the customer service. So the pure virtual, probably the pure virtual, contact, company enable the customer to interact. There is a, virtual services like eBay where they do customers interact with each other, and you got specialized like eBay and Second Life. And companies enable customers to interact with one another in an open environment. In the mixed virtual, actually customer contact customers and they interact with one another in a server moderate, so they don't define like, YouTube, Wikipedia, it's defined in that level where you can, interact as a customer with a customer. It's two different virtual way of communication, customer with a customer. So in the case of Padlet, you have two options, which is a pure virtual customer, classmate interaction, or a mixed virtual, which is that's what we are doing. We're putting certain subject, and you need to do Padlet interaction. Now, before we finish the class, I want to say one thing. Some of you are active in the Padlet, and some of you are not. Now, I put a 10% in the class participation. This is class participation. One depends on how active you are on Padlet, how active you are in the class participation, when I'm creating rooms, when I'm doing a polls. But mostly today, I'm looking at the class. You need to respond to the Padlet and put your comment there and write things. So I'm regularly looking at that. And please, if you're not participating, that means you're not interested in the 10% of your total marks. Okay, I think I'm done here. Let me know if you have any question. Otherwise, please feel free to leave. Okay, so there is no questions. I got your assignments. I'm responding to every assignment. Hopefully we can finish it up very soon.
Excuse me, sir.
Yes.
Some of our class students get their marks for midterm, but some of them are not.
That's not true. I haven't put the marks in for the midterm.
No, I didn't get that. One of my friends is also not get the marks.
No, I haven't posted any midterm test yet.
Okay.
Yeah. So yeah, don't worry about it. If somebody said I got it, he's probably or she's probably dreaming or something. So don't worry about it.
Thank you, sir.
No problem. You will get a mail, and probably everybody will be notified once the marks is changed. It's
Okay,
put there.
sir.
Okay.
Okay, sir.
So
thank you.
no problem. You guys have a nice day and enjoy the rest of the week. Hopefully, I will spend my week correcting tons of tests and assignments.
Okay.
Okay. Bye-bye.
Thank you, sir. Bye.
Bye-bye.